Previous hands-on, we have seen about the real-time analytics with Fabric, and then we saw about the event streams in detail. And I guess yesterday you would have learned the theory part of this event house. So today we will continue with the hands-on of event house. Basically, after event streams, the next is event house. So today we'll be seeing how do we query with this event house using KQL and TSQL. So for that, first thing is we will have to create a workspace. So I'll give the name of the workspace as event store demo, and I'll apply so that the workspace gets created. Now, once the workspace is created, we will go to the real-time hub that is present over here. Click on this. So once you click on this, so you'll be able to see the all the things in the real-time hub, like the one lake and the job events, all the things. So we do have some sample event houses and sample data, basically a sample complete real-time hub. So from there, we'll pick up one sample data. I'll take up the bike rentals, and here I will just take up the event house and the event stream, and the destination should be our workspace. So whenever we are creating a sample real-time analytics or the database through the event house or anything, whenever we are creating the sample for this real time, we need to create through this event real time. So whenever we are creating the sample, we have to ensure all these things. As of now, we are only going through today's hands-on is going through this event house. So I have unselected all of these things, and even this query set, we will see how to get this query set out of it. So now select your current workspace, in the sense whatever the workspace you have created. So I have created the event store demo. So I'll be selecting that, and this will be the folder name where it will be created under this workspace. So bike sample will be the folder name. Once you click on create, this will take a minute to load the sample data, that is the source data, event stream, and the event house to your workspace. So once this has been created, you'll get this pop-up. Just close it and close all these things and come back to your workspace. So once you come to your workspace, you will see this folder as bike sample. Click on it. That will give you the extended format of all the things. So what are the things inside it are like the event house and the event streams. You'll be able to see those things. So from here, you will have to select the event stream and see that the stream has been created from the source using the sample data, and it has been sent to one of the event house. So once if you verify this, then you can understand that the bicycles data is directly streamed using the event stream, and it is pushed to the destination, that is the event house. So this is a unique name given to a data event house because we have choose a sample event house too. So that is why we see this name of this event house as a unique name with some kind of numbers and characters. So once you verify that the stream canvas is right, then we can go back to this workspace. So once you go back to the workspace, you can click on the event house. Now you will be able to see the database, that is the bike database over here. So you can see the system overview. It consists of around 23 KB of data. So there are only one database, and it has been active from past 2 minutes. And so there are total almost 333 rows ingested to this database in past 1 day. And so like these are the overview of the current database that has been created and where the data has already been ingested to this. So this was a sample data base, that is the KQL database, where the data has already been pushed to it. So under this database, you'll be able to see the database package set tables, and under the tables you'll be able to see that bike stream, and here are the shortcuts. So if you want to bring any KQL data warehouses or the lake houses, you can create the shortcut using this. These are the materialized views, and there are functions and data streams. So as of now, I want to query the data that is present in the bike database. This is a live view of the database, and if you just refresh it, you will get the fresh activities of this database. Now, in order to, so once you check for the data streams, you should be able to see the stream connection to this KQL. So you can check the data streams for this database using this option called data streams. So you should be able to see this bike DC data connection, which means that the data is being pushed as an event to this KQL database called bike. So bike database. So now, in order to query this, you can click on this query KQL query set and give a unique name to it. KQL query 1. Click on create. This will give an IDE to run the queries. So these are some of the tutorials. As of now, you can ignore this. Now, the first thing is we will query the table bike stream. So in order to query the table bike stream and get the first 100 rows. So every time we can't get all the rows in the stream. So we can just target to some 100 rows or 1000 rows or something like that, so that the performance of the database will be good. The query is optimized. So the syntax will be the table name with the pipe and take 100. Take 100 is nothing but the top 100. So the table name is bike stream and the pipe icon and take 100. So this will give the top 100 bike streams. So it is done in just 0.85 seconds and there are 100 rows. There are no hidden empty columns. Like you can hide the empty columns over here. As of now, I don't have any empty columns. And this is how you fetch the data. Like if you want to see the data, this is how you see the data. Now, let us choose some specific columns and select for top 10 rows. So suppose if I take from the bike stream, I need to only select two columns. That is street, comma, and no bikes. So there is a column called street and no bikes. So which are the streets that contains no bikes? So, and I will only need top 10 rows. So if you remember select in SQL, this project acts like a select keyword. It shows only the street and the no bikes columns, number of bikes columns for 10 rows. For top 10 rows, we need to use the keyword take and I'll mention 10. So this is how we select and query the columns. So in Listen Groove, there are 3 bikes, and Welton Road, there are 7 bikes, and in the Groove End Road, there are 2 bikes. It goes on until top in streets. Now let us try to rename a column because this no bike where there are no bikes. So let us make it proper because it is a number of bikes. So let us make the column name proper by renaming the column. Okay, so we have seen how to take top 100 rows, like how to select and see a sample of 100 rows of data in the table event stream database. And we have also seen how to select particular columns or visualize the data in a form of
Hi,
tables.
Nanda.
Hi, yeah, please tell
Hi,
me.
Nanda. Yeah, Nanda, line number 4, bike stream is a table name, right?
Yes, this
So,
is the table.
okay, so project street and no bikes is the columns we need to select it.
Yes, so I'll just run it again. So
Okay.
bike stream, I'm just seeing what and all columns are there and top 100 rows of in this
Okay.
particular table. So
Okay,
here we
top
could see
100
there are
rows.
like bike point ID, street, neighborhood, latitude and longitude, and
Okay.
there are no bikes, but it is not no bikes, it is the number of bikes.
Okay.
So we'll just correct this column name in our upcoming
Okay.
query and number of empty docs and the enqueue time. Enqueue time is nothing but the entry of this current data into this
Oh,
Eventhouse database, that is bike database.
okay. By default, it will be included in all the records, right? The include
Yes,
time.
this is a sample database, so it has been there in the sample database. So you can even like most of the streaming data will contain this date and time, like even whether you want or not, this will be there
Oh, okay.
because the data is identified based on the time itself,
Time.
right? Yeah.
Yes. So again, line number four,
So I'll be selecting only these two columns, that is street and the
street
number
and
of
number of
bikes.
bikes. Okay, line number eight, bike stream means the entire table will be displayed, right?
So if I tell bike stream, yeah, entire table might be
Okay, okay.
displayed, but
Still you
we
didn't
cannot
complete
go
the query.
with that. Any of the table, if you want to view it, we will not be
Mhm.
able to view the whole table because it contain like 3 million rows, 2 million rows or
Yeah, yeah.
something like that. So it's not
Oh,
the right way to query it. Either go with top 100 rows or top 1000 rows or something that has a better performance or better
yeah, yes.
optimized query would be good.
Okay, then. Thank you.
Okay, so now let us rename this column with no bikes to number of bikes so that the column will be clear. I'll use project and I'll give the new column name as number of. So this something writing in the SQL as publishing this column name has number of bikes. So this works something like that. So when I run this, I'll be able to see the street and the number of bikes. So I should have put one more, okay, as take. Now it's good. So the top 10 rows with the number of bikes are here. So now let us calculate using summarize keyword in order to get the total number of bikes altogether. So for that, can use bike stream. We'll use summarize over here because we need the sum of summarize as. So we have corrected the change the column name to number of bikes, right? So it should be sum of no bikes. Yes. So this will get the total number of bikes. So if you want to aggregate the data, then we will use the summarize keyword in KQL and the sum keyword to sum up the column. So this is how summarize is used in KQL.
So instead of sum, we need to use summarize, right?
No, sum will be used on top of the column name.
Okay, okay.
Summarize is something like, just give
So
me a
we have
second.
to use a function, right? We have to in summarize.
So we use like summarize keyword for the sum function. So this is how it has been
If
made.
we didn't give summarize, what will happen, Nanda? Total number of bikes equal to sum of number of bikes.
The query will fail.
Okay.
So it is a wrong syntax. So it
Okay, if we want to, I mean, use aggregate functions like sum or count or whatever it is, so it
hmm,
is mandatory to provide summarize, right?
summarize, yes.
Okay, can we check
Basically,
minimum?
to group by the things, it works as a group by itself. Like, let me get down to the group by part next, okay? So that you will get a difference between these two things. So it is only used to sum up the things. Like, if you want to group by on a particular column, like I want, as you can see, like now, if I take bike stream and I will use the same line. To summarize the bikes by neighborhood, and I want to project the neighborhood as total of bikes based on the neighborhood. So basically here what it happens is it groups the rows by the neighborhood and sums the bikes in each area. So when I run this, it groups on this neighborhood column. So whereas in the previous query, it was just totaling up the total number of bikes without any grouping. So it used to just sum up that whole column. So that is why we call it as summarize. We are not applying any group by to it. Once we apply a group by on a column, so it will be group by over the neighborhood column. Like, did you get the difference now?
Nanda, can you explain the neighborhood, the last one?
Okay. So in this last query, right? So we are taking the data from the bike stream and we are applying the summarize keyword to get the total number of bikes. And we'll apply the summation on the no bikes column and group by neighborhood, and we will select the neighborhood and the total number of bikes. Whereas here we only took this aggregation over the column no bikes, that is number of bikes. Here we are taking the aggregation of total number of bikes over the neighborhood, and we'll also select the neighborhood and the total number of bikes so that we'll get both the columns.
Nanda, you changed the column name from no bikes to total number of bikes, right?
Yes.
It is
Visualization.
not coming.
Yes.
Yeah, okay. So now we select all the columns, top 10 rows from the bike stream. Again, it will show the no bikes, right? Column name.
It'll be showing as no bikes. That's just like our like whenever you tell no bikes in the SQL as no bikes has number of bikes, then it will just take the column name as a view, not as the it doesn't change the column name in the database. Just to view it in a right manner, we can just change the name of the table. Like it will be, for example, I'll show you how to whenever we are querying it in the TSQL, right? I'll just show you the same set of queries over there so that you'll get the difference between these two. So, any more questions, guys?
So
Okay.
syntax is a bit confusing. We need to
Yeah,
work
yeah.
on it. Yeah.
Yes. This is the basic syntax. See,
Mhm.
and one more thing is like we can work in TSQL too, and we can work in the PySpark too. So, like we have different languages, but it has its own limitations. But
Mhm.
KQL is basically used for querying on the stream data.
Mhm.
And people who don't use KQL, they'll go with the PySpark. So
Okay.
because they would be doing the batch processing and all, and they'll be very
Yeah,
familiar
yeah.
with PySpark, they'll go with PySpark.
Mhm.
If even this is easy for people who are into KQL for a long time. Like people who are into SQL for a long time will use SQL, but
Yeah, it's same
SQL,
like SQL.
yeah, little more syntactical changes.
Yes, yes. So the pipe symbol is there, no, Nanda. That is what it means. If we want to type the code in next line, we need to use a pipe, right?
Yes, you're right.
Mhm.
So, like it is used for two purposes. So, first thing, it will separate the query operators in a tabular expression, and it is used for logical OR also. So, it is also used for that within the square or round brackets. So, to denote like as an operator also. So, these are the two use cases of this in this KQL. Let's go forward and let us write another one query in KQL itself. So I'll take bike stream and I will see if the neighborhood is blank or null and replace it with unidentified. So in this neighborhood column, if it is null or blank, right? So it has to give us unidentified in that column. So for that, I'll use the same query. And while projecting neighborhood, I'll give a case statement like case is empty and column name or is null column name. So as identity, so it will be over here as unidentified. So if there are nulls or blanks, it will be taken as unidentified on the column neighborhoods to remove the comma. Whenever it is going to sum up the number of bikes by neighborhood, so I have put a case if there is any blank on the neighborhood column or if there is any null value present in the neighborhood column, I want that to be specified as unidentified, and on which column it is, on the neighborhood column. So this is the case statement. This is how we use the case statement in KQL. And this is the total number of bikes which we have summarized over here. And let us run and see. I guess this data doesn't have any unidentified columns. So we are not able to see any unidentified columns because the data is clean when it has been, it is well maintained because it's a sample data, right? So this is how you can use a case statement. So
The,
yeah, please tell me.
Can we, instead of take 100, can we use the where neighborhood is empty or unidentified? How to write that?
That is how it has been specified. The condition is given in the case. We cannot use where over here in the KQL.
No, instead of selecting take 100, I mean, first 100 rows, is there any, whether we can, how to check the empty neighborhood? Did you
Okay,
get?
telling like you want to specify empty neighborhood, but in this data set there is no empty neighborhood as per I see over here. So even though if I put there, I'll get a null as I don't get any rows.
Rows, okay.
I'll just one more special thing about this KQL is if you want to sort or the data in particular order, you have two ways to do it. So one way is I'll take the same data. So here I'll apply, you can use sort by neighborhood in ascending order. This is one way. So this will sort in ascending order. And there's one more way to sort it, that is using order by. Even order by works good over here. It will be order by. So even the sort by neighborhood and order by neighborhood like gives the same output. The sort results will give you the same output. So these are the two ways how you can sort the data. So this is about sorting. Now let us see like how do we filter this KQL like particular column in our particular neighborhood, like you are asking for the unidentified, right? Let me do it for one of the neighborhood based on one of the neighborhood. So I'll take bike stream and I'll put a where condition and I will give it as West Chilsa. So it is where neighborhood is equal to West Chilsa. It has to be in, as it's a string, it has to be in double quotes. And I'll use the same set of code. Like here, the where conditions are applied in the initial itself. So this will get the data that is only belonging to the neighborhood West. Okay, there is something missing, comma.
There is a single and a double quotes stitch is
Oh,
here
okay,
starting.
yes, yeah. Now it should run. So now we are only able to get the particular neighborhood with the total number of bikes in that neighborhood. So like is your doubt clear now? Like how to put a where
Yeah,
condition?
yes.
Okay, so this is how we use a filter for a specific neighborhood, or if you want to use some filter condition, this is how we go by. So we can just ignore this. I guess order by doesn't play any role in this code. So if I give this much is enough. Yeah, so we can filter the using where condition like this. Whereas in the regular SQL, we will just use the where condition later, right? So over here, we will use it in the first stage itself. So let me summarize. So first thing is we have seen how to take a sample of 100 top 100 rows in a table. Then we have seen how to select the particular rows using project. Then we have also seen how to name the column with understandable name, not to replace it, just to name a column for our view. Then we have seen how to aggregate the data, how to use the aggregate function using summarize. And we have also seen how to group the data with aggregation using summarize and select the particular columns. Later on, we have also seen how to use a case statement on a particular column and query the data. That is, we have queried on the neighborhood column in order to replace the null columns with unidentified as the null data in a particular column with unidentified string. So now we have also seen how to sort the data. So there are two ways of sorting. We can use sort by function or we can use order by function. So both gives or yields the same result. Then we have seen how to filter a data based on a table. So using a where condition, this is used here. The where condition is used initially, and we have bought the sum of bikes by filtering the neighborhood. So this is all about querying in KQL. Now let us take another one tab and we'll query the same thing in TSQL. So whatever we have queried till now, we will query the same thing in the TSQL. So I'll just take select star top 10 bike stream. So this will get the top 100 rows from the bike stream. So this is how the TSQL is supported in KQL. So you can only run like minimal commands, but you cannot use alter, like it doesn't, you cannot use alter or you cannot drop anything or you cannot update anything in the table or you cannot even create a table or you cannot even delete the table. So in the event house, these things cannot be done using TSQL. So it sometimes also doesn't even support some SQL functions and syntax that are not compatible with this KQL. So basically, more of the operations are done in the KQL. Like now, let us go ahead and like select the. So here are some queries. So and select the top 10 rows, the street and the number of bikes. So again, it gives the same results. And similarly, I'll take this time the empty number of docs. So there is a no empty docs as a column name. I need that column name as number of empty docs when I'm viewing this table. So I have put I need to view this column as number of empty docs from the bike stream. So this is how I can rename a column just to view the data using TSQL. But still, this is also supporting in KQL. Now let us like get the total number of bikes using the sum function. We are able to get the total number of bikes using the sum function, like select sum on the column number of bikes as total number of bikes. So we are able to get even that. So now let us get the total number of bikes by grouping over the neighborhood. So we'll aggregate and group by neighborhood. So even that is also working. So you can see I have selected the neighborhood and it has total number of bikes and from bike stream and grouped over the neighborhood. So that is also supporting. So now coming to the select case statements, whereas there we used to have a single line case, whereas here we need to write a complete case like select case when neighborhood is null or neighborhood is empty, then it is identified, else neighborhood end as neighborhood. And we need to sum up the bikes, like the total number of bikes per neighborhood, and group by the clause. We'll be grouping by over the neighborhood. If it is null or empty string, then it will be unidentified. Else, the neighborhood name will be taken into consideration. So even we are grouping by over this case. So this is how we write it in TSQL. But whereas in the KQL, it was just a single line query where we had to just mention the whether it is using the he's empty function and the he's null function. So if the neighborhood is missing over here, it will be treated as unidentified. So the SQL requires the same case to appear in both select and group by. That is what it's happening in this. So now we will apply the sorting function over here. So it is the same query. We will be sorting it in ascending order, but here only we can only use order by. We cannot use sort by because SQL doesn't support sort. So once you use order by ascending or descending order, you will be able to see the output. So the sorting is also possible using TSQL or the KQL database. Now I need to filter the particular neighborhood. Then I have to write a big query. Like I have to select the case where neighborhood is null or neighborhood is unidentified. Then I have to sum up the bikes and name it as total number of bikes. And then I will have to group by the case also. Then I'll be using the having clause in order to get this particular neighborhood. There we'll be using the where clause, but here I'll be using the having clause. It won't support where sometimes, so we can use this having clause. So I guess where also works good. Okay, where is not working here because we have to use having itself. So there are certain things that are not supported with KQL database when you're writing in TSQL, when you're writing the queries in TSQL. So you should be aware of it. So with a small difference, whenever we are selecting the columns, we'll use project in KQL. Whereas in SQL we'll use select. To limit the rows, we'll use take, and here we'll use select top number of rows. And then if we have to filter, we'll use here where function, and we will in this TSQL we'll use having. And if we want to aggregate in KQL, we'll use summarize keyword, whereas here we'll use sum and group by. So if you want to like rename a column here, we will use the project keyword and we will give the new column name equal to the old column name, whereas here we'll use has a new column name in the TSQL. So in a conditional logic, like using case statements and all, like we'll use case function in the case keyword and function in the KQL. Whereas in the TSQL, as you can see over here, we'll use a case when clause. Whereas sorting, we can use sort by or order by in KQL, but in SQL it only works with order by. So that is the major difference of querying the KQL database in the KQL language and querying the KQL database in the SQL language. It's the same set of queries that has been run in two different languages. So any questions over here?
No, Nanda.
So this is how the data has been queried using KQL, and how TSQL also supports the KQL database. Like you can query the database using the TSQL up to a limit. Like you cannot use too much of TSQL. It has some limitation and differences when you use with the native SQL server. So this is about the KQL database and the Eventhouse in the real time in Fabric. So if there are any questions, I'm open to questions now.
Nanda, can you summarize today's?
Okay, so first thing is sample event house. Once we created our workspace, then we went to a real-time hub and we took a sample data from over here, from the sample gallery, and we took the bike rentals sample, and we just took this and we clicked on connect, so that whenever we are connecting this, we just only took the event house and the event streams. We unchecked all other items like the dashboards, activator, Power BI, and query set. And this took like a minute or to load the data, the sample data event house. So once this was loaded, we went to our workspace and we checked the data in the event streams, whether the source and the destinations are proper. So once it was seen it has been properly fixed, then we went to the event house. So in the event house, we checked for the extreme table and we started querying it over the table. So in the KQL language. So in the KQL language, we just saw how to view first 100 rows. And first 100 rows, then we saw how to select the street and the number of bikes with first 10 rows. And we saw how to rename a column for our output. and we saw how to get the total number of bikes, that is using the summarize keyword and using the sum function. And we have also seen like how to get total number of bikes per neighborhood by using group by, basically kind of group by kind of operations, the neighborhood column. We also saw how to use a case statement in this data table. Basically, we used a case statement to treat the null or the empty rows in the neighborhood as unidentified. Two ways of sorting the data, either by sort by or order by option. So both will yield the same result. And then we saw how to apply a filter on a particular column in KQL. We can use a where command over here, and we can filter it over the data, like we can filter over the neighborhood we have seen here by filtering over the neighborhood column. Now, the same set of queries are performed in TSQL. There are only minor changes, like we could get the top 10 data by selecting the columns, and we could also rename the columns using by has a view by using the keyword has and the new column name just for our output. And then we also saw the aggregation that is also working well with the KQL database using the TSQL. And we have also seen how to use group by using TSQL, even that is supporting in the KQL database, to query the KQL database data using the TSQL. Then we have used the case statement to treat the neighborhood rows which is null or null or empty has unidentified. That is also working fine. And we also try to use the having clause, that is also working good with TSQL on the KQL database. So finally, for sorting, we could only use order by in the TSQL, because TSQL doesn't support sort by. So sort by cannot be used in TSQL. So this is the overall summary of today's hands-on.
That's all for now. Like and subscribe and turn on notifications for future videos. Thank you.